Average velocity is a particle's displacement divided by the time interval during which that displacement occurs. The formula is v sub x avg equals delta x over delta t, where delta x is the displacement of our particle and delta t is the time interval. Delta x is equal to x final minus x initial. Expressed in y for objects that are moving in a vertical motion, the average velocity is also equal to v sub y comma avg equals delta y over delta t, where delta y is the displacement along the vertical and the delta t is the time interval. The units of average velocity are units of length divided by units of time. In SI unit, that is meters per second. Average velocity for one-dimensional motion can be positive or negative. It depends on the displacement. Because the time interval is always positive, because time always moves forward, the sign of the average velocity depends on the sign of the displacement. If the displacement is positive, then the average velocity is also positive. If the displacement is negative, then the average velocity is also negative. Let's say, for example, we have a particle that is moving along the x-axis and its motion is plotted in this position versus time graph. The average velocity of the object as it moves from A to B is actually the slope of a line that joins A and B. As you can see here in this graph, I drew a line that joins A and B, and the slope of this line is just the rise over the run, and as it turns out, the rise is the displacement delta x, and the run is the time interval delta t. Rise over run equals delta x over delta t. What is the average velocity of the particle as it moves from point A to point B? Notice that at point A, at time equals 0 seconds, the object is at 30 meters. And at time D, the object is now at 0 meters. Back to the origin. To solve this problem, we note that the slope of this line is the average velocity, rise over run. Our rise is the displacement, which happens to be the final minus the initial position, or 0 minus 30. That's why we get negative 30 meters for our displacement. Our time interval is from 0 seconds to 30 seconds, or 30 minus 0, which means that our time interval is 30 seconds. And so the slope of this line, or the average velocity of the particle from point A to point B, is negative 1 meters per second. Let's have an example. A particle moves according to the equation x equals 10t squared, where x is in meters and t is in seconds. Find the average velocity for the time interval from 2 seconds to 3 seconds. Note that the motion of our particle is described completely. For every time, we have an equivalent position. Whatever you substitute in that equation for the value of t, you will get a position value for x. So we know exactly where the object is for every time. In fact, we can come up with a table If we just substitute the values, if t is equal 0, what is x? If t equals 1, x is 10, like this. I use an Excel to do this. When t equals 2 seconds here in the left side of your screen, we substituted that to the formula and we got x equals 40 meters. When t equals 3 seconds, we got x equals 90 meters. So we now know that the displacement of the particle is from 90 minus 40 meters. This is the graph. I use Desmos of x equals 10t squared. And this is a graph of position versus time. So we know that for each time, we have an exact value for the position of the object. So, using the formula for average velocity, delta x is 90 minus 40 all over our delta time is from 3 seconds to 2 seconds because that is the time interval that we considered in our problem. So 9 minus 40 is 50 divided by 3 minus 2, which is 1. 50 divided by 1, we get that the average velocity of the object is 50 meters per second. Thanks for watching. How do I stop the recording?